Okay, sure. So we start with our unit number 1, that is linear differential, higher order linear differential equations and application. So before we start, we need its definition. So definition, you should also write with me. So definition, a differential equation. Yesterday we have discussed about differential equation. It should be the equation and it is a differential, means derivative should be in it. Such equations, a differential equation which contains the differential coefficients. What are differential coefficients? Like dy by dx, this derivative terms, and dependent variables. What are dependent variables? And dependent variable in the first degree. Degree should be 1 of that dependent variable. Dependent is what? If it is dy by dx, then that y is dependent variable. And dependent variable in the first degree does not involve the product of two derivative terms. The product of one derivative with another derivative or with dependent variable What should not be there? Differential equation, dependent variable must be in first degree. Degree should be 1 of that dependent variable, in which there are no multiplication of two derivative terms together, like dy by dx into d2y by dx square. So does not involve such products of two derivatives together, or one derivative with dependent variable like y into dy by dx, y into d2y by dx square. So such things should also be avoided. Product of derivative with derivative and derivative with dependent variable, this should be avoided. And in which, yes
अनदर
beta,
ले 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 डेरिवेटिव
sorry,
है का
yes, it is derivative. Product of one derivative with another derivative or with dependent variable, and in which the coefficients, what are coefficients? Like if it is 2 d2y by dx square, so 2, 2, 3, 4, these constants are called coefficients. These coefficients are constants. They should be constant numbers. Then it is called a linear differential equations with constant coefficients. This is the definition of linear differential equations with constant coefficients. So first thing is linear differential equation. What is it? There should be the terms of derivative which can have any order, but degree of each term must be 1, right? In the first degree, so degree should be 1. There should not be product of two derivatives, or there should not be a product of a derivative and a dependent variable, and in which if the coefficients are constant, okay, they can be constant or they can be variable. So first definition is of constant. We'll see first part as constant coefficients. Okay, then the general form of such differential equations, we call it as LDE, linear differential equations, is, okay, what I'm saying, order can be anything. So order is say n. So what is the derivative term? nth derivative dny by dx raised to n. Order can be anything, so order is n. There is such term, but degree should be 1. So its power, it should be 1. It should not be like 2, 3, 4. Then degree will change, right? So it should be 1. So such terms are there with degree 1. Derivative is there. Some higher or lower order can also be there. So say there is dny, dn minus 1. This derivative is also there, n minus 1th derivative term. Then say one more less than that, n minus 2th derivative, right? And then say there is d2y by dx square. Then there is dy by dx, and y is dependent variable. So there is say y, right? And what I'm saying, multiplication of two derivatives should be avoided. Yes, there is no such term which, and y should not be multiplied to any of this. And these are multiplied with some constant coefficient. So a naught, say here is a1, a2, so on. Say it is an minus 1, say it is an. These are some constant coefficients. And if we add them together, or there is some subtraction like terms, this becomes an equation if there is equal to some function of, it should be the function of independent variable. Independent variable is x. So say if it is function of x, then such a form is called LDE with constant coefficients where a naught, a1, so on, an are constants. Then such a form is called LDE. Are you getting? Any order derivative with a degree 1, every term is having degree 1, power is 1, right? No multiplication, nowhere you can see the multiplication of two derivatives or a derivative and y is dependent in this case. So no such terms are there. So such a form is called a LDE. Getting? So now in this, throughout this unit, you have to use d by dx as capital D. Okay? So in this equation, we'll substitute d by dx as capital D. So what we'll get is a naught d by dx is d. So it is d raised to n. D by dx raised to n, that is d raised to n, and y is there. Y. Call it as equation 1. So 1 becomes. Next term is, that's a1. What is next term? What will be the next term? A1.
d raised to power n minus 1 into
Yes,
y.
d raised to n minus 1. Y. What is d? You will always remember d is a derivative. Please remember, d is not just a simple operator like yx. It is a derivative operator, d by dx. Okay? Plus a2, d raised to n minus 2 y, plus so on up to an minus 1 dy plus an y is equal to f of x. Okay, and if you can see in your left hand side, every term is having y in it. Y. So that y will take it outside as common. A naught d raised to n, a1 d raised to n minus 1 plus so on, an minus 1 d plus an, this term, this term, this term. Just y we have taken out as common. Okay, is equal to f of x. Now this is how is this? A naught, a1, a2, these are constants. D, these are terms raised to power. So it is like 2d square plus 3d plus 2, 5d cube plus 2d plus 4, 2x square plus 3x plus 2. This we call as this is a polynomial. This form is a polynomial. So where let whatever is this, we'll call it a some function of d. This is a function of d. Like आपण म्हणतो ना, what we call x square plus 2x plus 1 is equal to f of x. This is a polynomial of x, right? So as a f is already used, so we'll use phi, other variable. So phi of d into, sorry, let phi of d call first. Phi of d is a naught d raised to n. Call this phi of d plus an minus 1d plus an, this term. The whole term we'll call as some function of d. So this becomes phi of d. This is phi of d into y is equal to f of x. This is the general form of LDE with constant coefficient. Some function of d into y is equal to f of x, where phi of d is a polynomial in d, is a polynomial in d. Isn't it? Polynomial a naught a1, if we can write 2d square plus 3d plus 2, which is a polynomial. This is a polynomial. Polynomial is always of this form. Okay, so this is the standard form now. Everyone will remember this form. Note. Phi dy is equal to f of x. Phi dy is equal to f of x LDE. This is the standard form. There are two broadest types. First type is called homogeneous LDE and second is non-homogeneous LDE. What is homogeneous? If that is equal to 0, if your function on the right hand side, if its value is 0, that is equation, if it is equal to 0, that is called homogeneous. And if it is non-zero, there is some function. So I'll call it as f of x itself. So if there is non-zero term, then this is non-homogeneous. LDE are of two types for your study. First is phi dy if the first is equal to 0 and second if it is not equal to 0, there is some function f of x. Okay, so now we will go for first type. So first type 1. Solution of homogeneous LDE, that is phi dy equal to 0 type, first type. This is the form. There are two types. First is equal to 0, second is non-zero. So we are going to see first form, whether if your equation is equal to 0. Here we can solve any equation of order anything, just degrees 1. Okay, how to solve? So first thing is, we have an equation. Consider that equation. Consider phi dy equal to 0. Where, what is phi d? Phi d is a polynomial. Phi of d is something like a naught d raised to n plus a1 d raised to n minus 1 plus so on an minus 1 d plus an. A polynomial, any polynomial, right? So your first job is then factorize this phi of d. Yesterday we have seen what is a factorization. factorize phi of d in linear factors. In linear factors. How to factorize? I will tell you on your calculator how to do that. But first thing is you have to factorize. So say after factorization, this is nth order equation, so there can be n factors. So say the first factor is like d minus m1, then into d minus say m2, into so on up to d minus, say there are such m factors. How many factors? N factors, because order is n. Then what? Everything will equal to 0 and there will be roots. So what are the roots? Where this m1, m2, so on up to mn are the roots. First factorization, then if we equate it to 0, we will get the roots. Okay, so your job is to find out roots, right? So up to roots it is done. First thing is auxiliary equation or definition. We will need this auxiliary equation. What is the auxiliary equation? The equation phi of d, whatever is your phi of d in this, that phi of d, if we equal it to 0, if we equate it to 0, phi of d means just ignore the variable y for some time, and if we equate that phi of d to 0, that is called an auxiliary equation, is called auxiliary equation. Okay, so first thing, if we get this type of equation homogeneous, first you have to factorize and you have to find out the roots. Okay, then depending upon the roots, there are 4 types of solutions. 4 types of solutions. Now first we'll clear up to this and then we'll see what are those 4 types. What I mean to say here, I will tell you. For example, if you have, it's little blind, right? You are little blind now. So let me give you one way to think. Just a minute. Okay. So what I mean is, if your equation is like 2 d2y by dx square plus 3 dy by dx plus y is equal to 0. Such equation, whether it is a linear differential equation, yes, it is order 2 but degree is 1, order 1 degree 1, everywhere. Nowhere 2 derivatives are multiplied, nowhere y is multiplied to something, right? So it is a LDE. Then we have to solve this. Okay, so what is your first step? Let me go here. What is your first step? You have to substitute d by dx as capital D. Okay, so do that. Put d by dx as capital D. So your equation becomes 2d square y plus 3dy plus y is equal to 0. Okay, the next is y we should take out common. Here y everywhere, so we'll take it out. 2d square plus 3d plus 1 y is equal to 0. Are you getting? Now we are up to this. That is of the type phi dy equal to 0. The first type, phi dy equal to 0. Phi d is any equation in capital D. So this is the equation in capital D into y is equal to 0. right? To solve such equations, what you have to do is you have to factorize that phi of d into linear factors, and you have to, we are interested in this, we have to find out the roots. Just find out the roots of this equation. To finding the roots, you have to consider the auxiliary equation, and depending on the roots there are, we'll see it later, four types of equation. Just to solve phi dy equal to 0, we have to first consider auxiliary equation. Phi dy equal to 0, so we have to consider phi d, 2d square plus 3d plus 1, only this part, equate it to 0 and find the roots. Okay, find the roots. How to find the roots? Now you can solve by your usual way, or we have a calculator. Just let me make a correction so that it will be easier for us to, and 20, okay, please, huh? So it will be easier for us. I'm just writing 2 here, removing this 2. Huh. So that will be easier for us. No need of calculator right now. First we put d by dx, then we make an equation, take out y, we have considered auxiliary equation. So how can you factor this equation? How can you factorize? How can we factorize? Their multiplication, there should be two terms whose multiplication should be 2 and whose addition should be 3. Which are these two terms whose multiplication is 2 and addition is 3?
2 and 1.
Yes, 2 and 1. So 2 and 1. Multiplication is 2 and we need 3. So if we add, it is 3. So first thing is, what I mean, I'm telling you, factorize this phi d. This is your phi d. Take that auxiliary equation, factorize it. So its factors are d plus 2 and d plus 1 into d plus 1 is 0. So equate everything to 0. D plus 2 is 0. D plus 1 is 0. So what we get here, d is minus 2 and d is minus 1. Now what we get, these are called roots. We are interested in these values. So can you just take out your calculator right now if you have? Or forget, let it be. We'll first see and then I'll tell you. But be ready with your calculator for next lecture, okay? We are here. We have to factorize and we have to find out roots. Find out roots. Depending on these roots, we are going to write the solution. So depending on these roots, there are 4 types of solutions. First type, if roots are real and different. Real and different. Real. What are real? Which numbers are real numbers? Can you just tell me real numbers? 2, 1, 2, 3, minus 1, minus 2, 0, square root 2, square root 3, 2 by 3, 3 by 2, e raised to something. Are all these real? Yes, all the numbers are real. Which numbers? All the integers, all rationals, irrationals, positive, negative integers, rationals, irrationals, all the numbers are real numbers except what? Those numbers are not real numbers except the complex numbers. And complex are of, yes, complex numbers are of the form, which form? What is the form of complex number? Do you know this form? Alpha plus minus I beta. wherever there is I comes, that I is square root minus 1, and this form is called a complex form. Wherever in your equation there is I, that is called a complex number, like 2 plus 3i, or 2 minus 3i, 3 plus 4i. Once I comes, it is not real. So all the numbers except I are real numbers. Good. So all the numbers are real except complex. If we get such real roots, and whatever we get the roots, they are all different. What we get here? How is the nature of these roots? How is the nature? Real hai? Is this real?
Yes.
Yes, ma'am.
Yes. Is this
Yes.
real? Yes. Both are real. Real and both are different from each other. Are they same? No. They
No.
are different. Yes. So this nature is real and different. So depends in your equation, given equation, how, what roots we are getting, how are they are real or different, they are real or repeated, they are complex or they are complex or repeated. Such four types are there. Which for real and different. Sometimes you can get the roots 1 1 1 also, real and repeated. Second type, real and repeated. Sometimes we can get the root 2 plus minus 3i. Roots are imaginary. And sometimes we can get 2 plus minus 3i twice. So it is imaginary and repeated. So these are four types. 1, 2, 3, 4. Okay. So we are going to see now the first type. If the roots are real and different. Roots are real and different. So say, these are the roots. We are talking in general. So let m1, m2, so on, mn, whatever are the roots, are all real and different. If such thing is there, then we can write the solution as therefore. Then solution, we are writing for this equation where dy by dx is there. This is dy by dx derivative. So we get the solution y is equal to some function of x. Okay, dependent variable is equal to function of independent variable. So here we get y is equal to, please listen, m1 is the first root. Up whatever solution we are getting, this is in y and x. Y is equal to some function of x because it was dy by dx. So it is y is function of x. If it is originally like ds by dt, so how will you get the equation? Get the solution?
Y is equal to f of s.
Yes, s is some function of t. S is function of t. Understand the variable.
Yes, ma'am.
As we are talking in general, so in general we use dy by dx. Always variable, you must change the variable. You never should write y is function of x. You should write s is function of t. Okay, so here y is equal to, back to track. Okay, these are the roots, they are all real. So how do we write the solution is, first root is m1, that root you will write in the power of e raised to m1, independent variable is x, so multiply by x, e raised to m1 x, and write one constant to this c1 say.
मॅम हे सॉल्व केलेल्या प्रॉब्लेम मध्येच खाली लिहायचंय का?
Yes, that is the solution. Just this is a method. You have to remember this method. Wait, this is method. You should not write. Wait, don't write this example in between. I'm just telling you this how to do that. You are writing theory only. Roots are real and different. So suppose these are the roots. These are all real and different. Then the solution of this is y is equal to First root is m1, so c1 e raised to m1x plus second root is m2. That root also should go to the power of e raised to m2x, and it should give next constant c2. So what should be the next term? Can you just tell me the next term? Suppose m3 is the next root. Come on.
C3 into e raised to m3
Very,
x.
very good. Every term should get different